Space may be perceived as the final frontier to explore new worlds, a place where barely anyone has gone. But yet there's the possibility of getting a very close look at distant galaxies without travelling on a spaceship. Over the past years, researchers at the University of Portsmouth have been collaborating with their counterparts across the world to create the most accurate image of the night sky.
I've been involved since 2004 in a project called the Dark Energy Survey, which is an international survey dedicated to looking at the universe as deep and as far as possible to try and understand a phenomena that we call dark energy. This phenomena is a very strange property of the universe in that it appears to dominate the contents of the universe. So 70% of the universe appears to be this thing called dark energy. And it appears to behave very differently from any other phenomena we know of, in that unlike gravity, which sucks and brings things together, dark energy appears to be repulsive and drives things apart. So at present, the universe is dominated by dark energy and appears to be driving galaxies further and further apart, faster and faster. And really, we have no concrete physical explanation for what this dark energy could be. We can measure this acceleration of the expansion of the universe. We just don't know what's causing it.
About 400 scientists were involved in the Dark Energy Survey.
We spent 14 years building a new camera, one of the world's largest digital cameras, which we put on a telescope in Chile. It took 10 years to build the camera. Then it's taken 4 years to basically point the camera at the night sky and collect very deep, detailed images of the night sky, which we then have to stitch together to make a map of the sky. So in essence, what we've done is made one of the biggest, deepest digital images of the night sky. But what we're looking for is we then use that image to find as many of the distant galaxies as we can. And we've discovered hundreds of millions of distant galaxies. And for each one of those distant galaxies, we make an accurate measurement of the size and shape of those galaxies. And it is from the sizes and shapes of those individual millions of galaxies that we can interpret the dark universe. You can't see it on any individual galaxy, but when you have millions of these galaxies together, you can start making a map of the dark matter and dark energy.
The outcome of the study confirms that 70% of the universe is made up of dark energy and another 25% of dark matter.
In total, 95% of our universe is dark. It doesn't shine, but it is out there. So we've confirmed that beyond any reasonable doubt. It is now unquestionable that our universe is dominated by this dark stuff. We also, quite interestingly, reconfirmed Einstein's theory of general relativity. So it turns out that we are applying the laws of gravity we've developed on this planet across the whole cosmos. So if you take the formulae that Einstein developed 100 years ago, they seem to work, which is again a great feat of human endeavor.
For the survey, a technique called blinding was being used.
We try, while we analyze our data, to not look at the result as we're analyzing it. It is incredibly difficult to do. You can imagine the temptation is to always look inside the box and see what you see. But the reason we do that is that we want to avoid any unconscious bias of what we expect the answer to be, influencing what the answer will be. The scientists only really knew the answer a couple of weeks before we announced it to the public. So it was a shock to us. We're still kind of trying to understand what it means. Ironically, we found an answer that was consistent with previous data, but it could not have been that way. It could have been that we found a very different answer, but then we would have to have lived with it, and we would be I would be being interviewed trying to explain a different answer than the one what we got previously. But that's the fun of it. And also it means you can trust the data or trust the result a lot more because you feel you've not influenced it along the way.
Nicole Ris, That's TV.